A functional group in organic chemistry is something that dictates a particular organic chemical's chemical reactivity and properties and all that sort of stuff. And I'll get onto what things affect a chemical's physical properties. But if you imagine a base organic molecule, organic chemistry is based off of carbon chains, because these carbon chains are things that were formed millions and millions of years ago when sediments were sort of fossils and like living plant and animal matter was crushed under things like rocks and non-living matter under very high pressures. Don't even know about temperature, but in the absence of oxygen, so things couldn't decompose them. Things like crude oil were formed, and these were like long hydrocarbon chains. And that is the most basic sort of organic molecule that you can possibly fathom. And even the basic organic molecule, the CC bond, single bond, is technically a functional group known as an alkane. This has properties which means that it can combust, and it's like able to like go up in flames and be burnt and release certain gases and stuff like that. But it can also react with chemicals such as chlorine and fluorine and the sort of halogen gases when you consider the periodic table. So even then, an alkane, the simplest sort of homologous series and functional group that exists, is still technically has its own chemical properties. But if you imagine something like an alkene, which has the only difference from an alkane and an alkene is one carbon-carbon double bond, but that single like electron rich sort of site with the double bond means that it has different chemical reactivity and properties to the like the alkane and the long hydrocarbon chain. When that was explained to me in that particular way, where any functional group, whether it's like an alcohol group, whether it's carboxylic acid, an aldehyde, means that it affects its chemical reactivity because each functional group participates in many different reaction mechanisms because of things like bond polarities, free radicalization, and all that sort of stuff. If a functional group has sort of a different mechanism with a different functional group, then that thing can be considered a functional group because it is different in some sort of way. But if there are two sort of things, if you imagine like a big molecule, that molecule in itself isn't a functional group because it's like there's too many different sort of mechanisms, but individually there will be functional groups inside of it that are going to mean that when that molecule reacts, it's going to have like different sort of molecules and electrons and atoms like taken off it and stuff like that, and it's going to have free radicals, and it's very interesting, and it's also very complicated. But in this video I'm just going to go through a few functional groups that I know of. I'm going to just list like straight up as many as I know. I probably won't go into much detail on each of them, but I'll just start from the most basic, and I'll probably end up missing one out on the way just by accident and then coming back to it like later on. But there are honestly so many functional groups out there because there are so many different bond sort of I don't know how to say it. There's so many different bond types that can exist. You can have like a nitrogen bonded to a carbon, then you can have a nitrogen double bonded to an oxygen. There's going to be so many different combinations of like how a certain like part of a molecule is placed. That's going to mean that it ends up being more interesting and has different chemical reactivities and properties. But the first functional group is an alkane. The second functional group I know of is an alkene. And I'm just going to go in the order of the stuff that I've learned and researched. The third functional group that I know is an alcohol. It's got an OH group. This means that it can dissolve in water a lot better than the other molecules that I've listed, such as alkenes and alkanes. Then you're going to have things like alkyne, which is a carbon-carbon triple bond. You're then going to have things like carboxylic acids, which because of the way that it's structured, the two oxygen bonds, it means that this is actually an acid, and unlike many other sort of organic molecules, you're then going to have an aldehyde, which is instead of the OH group on the carboxylic acid, you just have a hydrogen. Often some of these chemicals, not for any particular reason that I know of, are quite carcinogenic. Formaldehyde, acetaldehyde, there's another chemical known as 4-HNE. All of these three chemicals are aldehydes, and it might be something to do with the functional group and the way that aldehydes react with things such as your DNA, which is what may be the reason that it's carcinogenic. That means that, and it may be the way that aldehydes are structured and the way that the functional group in aldehyde affects the chemical's reactivity, that means that it can mutate DNA and actually be carcinogenic, which is quite an interesting thing when you sort of think about it. But there might be on other bigger aldehydes with other sort of functional groups on it that means that this just doesn't really happen because there'll be so many different chemical reactions going on at one time that it might just not mutate DNA in the end for whatever particular reason, because I doubt every single aldehyde is like 100% a carcinogen, because that would be pretty odd for like nature to come up with something that's so like toxic and poisonous to humans without like us really being able to get rid of it in a weird sort of way. And then you have ketones, which is a CO double bond, and then it's going to have two R variable groups off the carbon. You're then going to have something such as you can then have something known as an anhydride, which is two of these bonded to an oxygen. Yeah, it's got like a C double bonded to an O, then an O, then another C double bonded to an O. This is known as an anhydride because it doesn't contain any hydrogens. The functional group, it's got two carbons and three oxygens without any hydrogen. So that's quite an unsaturated and particularly unusual molecule. You're then going to have an amine functional group, and this can then be split into primary, secondary, and tertiary amines, depending on how many hydrogens the base nitrogen amine group actually bonds to. And you're then going to have things such as an amide and an imide. I think an amide might be when the nitrogen is double bonded to a carbon, and an imide is when it's... I'm honestly not sure, but I'm going to put pictures of the functional groups up on the screen. I just know the names from things that I've read and things that I've like seen on the internet and stuff like that. There's even things like oximes where it's got like an N to a C and then to like an OH, and then yeah, it's all very confusing. But there's a point where some of the functional groups get so big that you wonder how the actual thing itself can have a particularly different sort of mechanism and chemical properties and reactivities than just like the different functional groups on the molecule. Because I read somewhere that urea itself was a functional group, which didn't make a lot of sense to me because urea itself has functional groups on it. It has two amine functional groups and it has a ketone functional group. So how the sort of smaller functional groups can be formed into one bigger one didn't make a lot of sense to me, so I'm not going to include urea as a functional group in this video. Then you're also going to have things such as halogenoalkanes, halogenoalkenes, and halogenoalkynes, which are just the three that I mentioned at the start of the video with a halogen added onto it. It can be as many as it wants as long as it doesn't sort of go beyond how many carbons there are in that sort of molecule, because otherwise that would just literally be impossible. Then there is things known as acyl chlorides, which is like a carboxylic acid group, but you replace the OH with a halide. You're then going to have aryl halides, which is where you've got a benzene ring connected to a halogen, and benzene itself, I think it's called an arene functional group. Benzene ring, because it is such a unique thing with the way that it can like donate its electrons to each other, and it's got like an electron density in the middle of the ring, that itself makes it quite an interesting functional group. And so instead of just being where it has three carbon single bonds and three carbon double bonds, that itself makes sort of sense as to how it's a functional group because it is such like a special chemical. But something such as a cycloalkane, where it would just be the sort of benzene form but there are no double bonds, that would just be an alkane because it has nothing particularly special about it. It doesn't do the things that benzene does. It doesn't participate in any different reaction mechanisms to what a normal straight alkane chain would in a way. So that means that just can't be classified as a functional group. But then as well as the halides, as well as the oxygens, the nitrogens, and the carbons, you've also got things like sulfur and phosphorus that are involved in organic chemistry. I know you can have phosphate groups. That's the only one I know for phosphorus, and that is very, very important in terms of biochemistry. And then for sulfur, you can have things like thiol. I'm probably going to miss quite a few of the sulfur ones out because I'm not very acquainted with that sort of stuff. You can have thiols, you can have dithiols, I assume. You can have things like sulfinic acids, I think. And then you can basically just replace the oxygen with the sulfur in a few of the sort of ones that I mentioned about the oxygen, because the thing with oxygen and sulfur is that oxygen and sulfur, they're in the same group in the periodic table. So that means they can bond a very similar amount of times. Because there are 8 groups in the periodic table, that discounting transition metals, lanthanides, actinides, and all that sort of stuff, there are 8 groups in the periodic table, and oxygen and sulfur in group 6. But the thing with sulfur is that it can also bond 6 times as well as 2 times, because it has like a d orbital where it can just push electron unbonding pairs up into. That's very, very advanced, but I just know that it can do that. I don't exactly know why or how, but it, as well as being able to bond to 2 things like oxygen can, it can bond to 6, but there are going to be so many other functional groups that, that's about all I know. I hope that I've been able to explain it well. I'll probably now put like a list of all the ones that I've mentioned like on the screen, but yeah, it's been very fun because I really do like organic chemistry and biochemistry. I personally think that they're the fields of the future, but maybe I'm just getting my hopes up because to be honest, I'm not particularly good at anything technological. I'm not like a computer scientist. I've never particularly been good at that. I've never particularly had an interest in things like AI and stuff. So I am really hoping that while I don't really want to go into the field of medicine specifically, I just think the field of organic chemistry and biochemistry, especially with an understanding of our health and how our bodies work and how chemicals work with the environment and climate change and all that sort of stuff, I genuinely feel like this is going to be a field of the future. Don't exactly take my word for it and follow me blindly, but I'm personally doing it because I have a very narrow selection of things that I really actually enjoy and am good at, and I think can have a good impact on the world. It's like the whole purpose and ikigai kind of thing that I know I've seen a lot of people talk about on the internet. But yeah, I do love talking about it, and I recommend subscribing to get more content like this. And I love this community of young tribal people who are willing to improve themselves so much more than they already have. And good luck.